Now for the case of dilute sodium chloride. Now when we're talking about something dilute or something concentrated, we're talking about something dissolved in water. And what happens unique in water when you add something, when an ionic compound dissolves in water, it ionizes. So you have sodium chloride. So that's going to be Na ions in the solution and chlorine ions in the solution. But what happens is the water in it also ionizes. So the H2O will break up into H plus ions and OH minus ions. Okay? So you have two cations in the solution and two anions in the solution. And this is getting tricky. Now only one of these two ions for each will ionize at their respective electrodes. So now you can see in this diagram over here, hydrogen and sodium, they have a positive charge. The cation is running towards the cathode, which has a negative charge. Similarly, you have all the anions going towards the anode because they have a negative charge. But between the two cations, only one cation will react, and between the two anions, only one of them will react. Okay? So over here, we'll talk about how we decide which one will react. But right now, we can see that hydrogen is reacting to form. Now, notice this hydrogen ion gains an electron, turns into hydrogen atom, right? Now, the atom is not stable, right? Because on its own, it only has one electron in its shell. It only has one shell, so its outer shell only has one electron, and it doesn't want that. It wants to complete its octet rule, which means for hydrogen's sake is that it wants two electrons. So they end up bonding. So hydrogen will end up bonding. So H plus ions turn into hydrogen and nothing happens to sodium. And between the, the anions, only one of them will react. And in this case, hydroxide ions react. And hydroxide ions, when they react, when they lose their electrons, they're losing electrons because they're next to the anode, right? They have a negative charge. They lose their electrons. They'll turn into water and electrons and oxygen. Now this equation is really important. They'll ask you 10 million times about this equation. Every other equation is just common sense. This is the equation that doesn't, so you kind of have to like work on this, like know that 4 hydroxide ions will turn into oxygen and 2 moles of water by giving out 4 electrons. ये तो होगा ही आपको थोड़ा ना, like you have to kind of learn this, ठीक है? Because they ask like 20 million times. So that'll be really good, ठीक है? The other thing is that when you're trying to identify what the product is. Now the product doesn't mean the equation. It's the product at the electrode kya banega? Like if they're talking about what's the product that was produced at the cathode. So you'll say hydrogen gas, nothing happened to sodium and hydrogen gas was given off, which is easily collected. Now what's the product at the anode? Well, you can say water, electrons still don't really count, you're taking them away. You could say water and oxygen, but that doesn't really make sense because this entire reaction happens underwater. So the pani just falls, like it just becomes indistinguishable from the rest of the water around. And the only noticeable product is oxygen, bubbles of oxygen coming out from here. So that's the noticeable bit. So if they ask for the product, you have to be kind of smart about picking what product you're picking. So for OH ions, you'll say the product is oxygen. Okay, let's move on. The hydrogen and oxygen bubble off, sodium and chloride ions are left behind. So we still have a solution of sodium chloride, right? So nothing's changing, it's just the water is decomposing. The overall result is that the water has been decomposed. That makes sense. Here's a question for you guys. What is happening to the concentration of sodium chloride? As more and more water leaves, because it's turning into oxygen and hydrogen, what's gonna happen to the concentration in the beaker, right? In the beaker we just saw, what's gonna happen to the concentration? Is it gonna increase or decrease? Think about that, answer in the comments, and we'll discuss it there. we have a third case. Now, you don't really have to see them as cases, but I like to see them as cases. The more granular it is, the better. So when it's concentrated, exactly the same thing places, the same thing results. But the only difference is when it's concentrated, there's something weird that happens to the anions. It's different for the anions. The rules are different, but we haven't discussed rules, so I won't discuss anything right now. Just know that there are three cases. One was it's molten, that's the easiest, and dilute is kind of straightforward. Concentration is this concentrated solutions being electrolyzed is exactly the same as dilute, just with one caveat, which is that anions उनके थोड़े differently react करते हैं. Cations will behave exactly the same. Anions is just that whatever is more concentrated, I'll say it. Whatever is more concentrated will decompose. ठीक है? Will discharge. That's the word, not decompose. ठीक है? The overall thing decomposes. ठीक है? But we'll discuss this in more detail in a bit. So in the image previously, you'll realize what the difference was, that instead of the hydroxide ion, the chloride ion was being discharged. So what was left in the solution was sodium hydroxide, sodium and hydroxide ions, right? So instead of a solution of sodium chloride, the chloride went away and sodium's going down. Now you have a solution of sodium hydroxide in it. ठीक है? I think I misspoke for a bit. Hydrogen is giving off, not sodium. Hydrogen and chlorine ion. So hydrogen and chlorine is being given off. And what's being left is sodium in the solution and hydroxide. So you have a solution of sodium hydroxide that's being formed. At which electrode does reduction always take place? Well, reduction is the gain of electrons. What electrode will give electrons? The cathode, because cathode has a negative charge. So no matter what happens, cathode pe to reduction honi chahiye. Cathode will always have reduction, and anode will always have oxidation take place on it, because that's what a negative terminal does. It gives electrons, and that's called a cathode. So reduction hi hogi. Anyway, give the half equation for the reaction at the anode during the electrolysis of these molten compounds. Molten compounds, there's nothing else present. Anode has a, let me write that down, has a positive charge, positive, right? Sorry, I keep doing that, it's funny to me. Positive charge, anode, let me double check. Yeah, cathode is negative, anode is positive. So यहाँ पे सारे जाएंगे, anode के पास जाएंगे anions. They'll go to it. Anions will have a negative charge. So potassium chloride में anion is Cl minus, and यहाँ पे O2 minus anion है, and they'll both discharge by giving out electrons, and they'll form Cl2 by giving out 2 electrons, and same for here. O2 by giving out 2 electrons. 2 each, just to balance it. Oh, I'm sorry, I think it's 4 electrons यहाँ पे. 4, right? And that's how it's balanced. Each oxygen gives out 2 electrons, so 2 will give out 4. Name the products at each electrode when these molten liquids are electrolyzed using inert electrodes. I like the word inert electrode, that shows a lot of things going on. देखो ना यहाँ पे क्या हो रहा है? Why it says inert is that magnesium, chlorine and different चीजें, copper वगैरह हम देख रहे होते हैं, they're all metals being turned into ions and ions turned into metals. So using electrodes should kind of raise a flag in your head. Why does it say inert? Because the electrodes are made of metal, right? So if they're made of metal, that means उस solution में आपने जो metal, जिस metal का electrode बना हुआ है, वो डाला हुआ है, right? Let's say copper का electrode है, तो that might react with this, so it might end up forming copper ions, or maybe something else happens. It might dissolve. Who knows? Anything could happen. So they highlight that it's an inert electrode, because those electrodes are generally made from graphite, like carbon, and they just do not take part in the reaction. They try their best to get an electrode made, which for that reaction at least is super inert, like does not react. Concentration वगैरह किसी में does not affect anything. ठीक है? Anyway, Magnesium chloride molten is being electrolyzed, and I want to figure out at each electrode. So let me, if I had more room, I should have given myself more room. So let's call this the cathode pair reaction, cathode pair not product, and anode pair. Now how am I working this out? Each of them, I just said cathode anode. अभी मुझे पता नहीं है कुछ भी, but I know cathode has a negative charge, so that makes anode have a positive charge. ठीक है? So magnesium chloride, so that's Mg2 plus and chlorine minus. So cathode पे it's going to magnesium 2 plus will go, right? Because opposite charges, positive will go to the negative. And वो ionize होगा तो neutralize होगा, discharge होगा, whatever. Don't say neutralize, by the way. Everyone kept saying neutralize. It's going to discharge and turn into what? Magnesium metal. And at the anode, chlorine will go and the product will be chlorine gas. Yeah, it's going to be sodium and chlorine gas. They're molten, right? It's straightforward. We haven't talked about the reactivity series yet, which we will in the next video.